Okay, so we are verifying the identity. That means I'm going to take one side and I want to make it look like the other side. So I'm going to start with this side because it's a little more complicated looking. And I notice that I have secant and cosine, but I don't have any kinds of squares. So when I'm thinking about rewriting things, I'm always going to be referencing, these identities. And a lot of them, we're going to be using Pythagorean identities, and they all have trig functions that are squared. Okay, so that means I can't go that route. So I'm going to try to write everything in terms of sine or cosine. So secant would be 1 over cosine. Then I have another secant, so that's 1 over cosine. And then this is just cosine. But I realize that when I have two separate fractions within a fraction, that I'm going to have to get a common denominator. So between these two, smallest thing that cosine x and 1 go into is cosine x. So I'm going to multiply this side by cosine x. So on top I have 1 over cosine x. Bottom we have 1 over cosine x plus cosine squared x over cosine. All right, so now I can put these two fractions in the denominator together. So again, keeping the top. And I've got 1 plus cosine squared x over cosine x. Well, now I see that I have 1 plus cosine squared over cosine. So I have a fraction over another fraction. So I'm going to multiply the top fraction by the reciprocal of the bottom. So diagonally, these cancel, leaving me with 1 over 1 plus cosine squared x, which is exactly what I am looking for. All right, second one. I kind of have either side would be fine to work with. Okay, I am going to work with the left-hand side. So I see that I'm turning into secants and cotangents. And on this side, I have tangent and cosecant. And if you look at your Pythagorean identities, tangent goes hand in hand with the secant, and cotangent goes hand in hand with the cosecant. And that's kind of like what we have on opposite sides. So I'm going to go that route. And if I were to rearrange this and solve for tangent squared, I would just subtract the 1. So I can replace tangent squared with secant squared theta minus 1. And then same thing with the cosine, I can replace it with cotangent squared plus 1. Negative 1 and positive 1 cancel, leaving me with secant squared x plus cotangent squared x, which is the other side. Okay, number 3. So this is definitely the more complicated side. And I do have a tangent squared, but I don't know that that's going to do anything. And if I notice, I'm trying to get down to sine. So I'm going to start by writing everything in terms of sine and cosine. So I've got cosine, tangent squared is sine squared over cosine squared. And cotan is cosine over sine. So if I actually multiply it across so that we can see it better, I get cosine times cosine would give me cosine squared. And then I'd have the sine squared all over cosine squared times sine squared. So what happens here is, oh, sorry guys, that's not a squared. There we go. So what happens is my cosines are going to cancel, and then I have 2 on top and 1 on bottom of the sine, so I'll take 1 from each, leaving me with sine. This step really isn't needed. You could cancel from here, like, okay, I can take 1 from here, and then, oh, I have another 1, so I can take 1 from here, and then I have 1 here, and be done there. Okay, the last of the verifying. This side's already in terms of sine and cosine, so I think I'm going to change this side to be the same. So tangent is sine over cosine, so I've got sine squared over cosine squared. And secant is 1 over cosine. So now I have 2 fractions, one over another, so I'm going to keep the top and multiply by the reciprocal of the bottom. So I have a cosine here and 1 here, so that leaves me with sine squared x over cosine x. All right, so we're using the half angle identities. So first off, I'm just going to decide where 15 degrees is. I know that that's in the first quadrant, and in the first quadrant, everything is positive. If I'm using the half angle, I'm going to need to double this. So really, the u we're going to be looking at is 30 degrees. And since this is cosine, I'll use the cosine formula. So I've got 1 plus cosine u, which is 30, all over 2. So I'm going to figure out what the cosine of 30 is. And I really think if we pull up our calculator, you can input what you think cosine 30 is off of your unit circle. I mean, if you pulled up your unit circle, cosine of 30 would be square root of 3 over 2. But you can actually take one step away and just make sure you're in degrees because you're using degrees. So you've got 1 plus cosine of 30 all over 2. And it's going to tell you that it's the square root of 3 plus 2 over 4. So you've got square root of 3 plus 2 over 4. And that's underneath this big square root, so you don't want to include that when you plug it in. Then all you got to do is square root the top and the bottom. So if I square root the top, you can't split that up, so like that, and then the square root of 4 is 2. And like I said, you're in the first quadrant, so this root is positive. So 195, if we think about that, that is going to be in the third quadrant, because this is 180, right? A little bit past that. So I'm in the third quadrant, and in the third quadrant, sine is going to be negative. All right? So I need to double the 195, so that'll make 390. And then I'm going to plug into the sine half angle formula. So I have a negative square root of 1 minus cosine 390 all over 2. And again, we should be able to just plug that directly in, but we'll make sure. So 1 minus cosine of 390 all over 2. We get negative square root of 3 plus 2 over 4. Square root the top. And the square root of 4 is 2. So important things to remember is make sure you double. Make sure you use this angle to tell what quadrant you're in, because that's going to tell you what sign to use on the sine and the cosine ones. Okay, number 7, we're finding the exact value of each. So I'm looking at this, and I see that I have cosine double angle. So if you look at your double angle formulas, cosine has 3 options. You have an option where you can use sine and cosine. You have an option where you can just use cosine, or you have an option where you can just use sine. So I don't really need to draw out my triangle, okay? However, you can if you want to. So 4 pi would be like 2 revolutions around, and so I'm going to be in this quadrant because that was the back end. So just for kicks and giggles here, sine is -4/5, so that'd be opposite over hypotenuse, which is going to make this other side 3, because I know my Pythagorean triples. Okay, so I actually really don't need that though, because I have sine, so I could just use the sine double angle formula. So that would be 1 minus 2 sine theta is -4/5 squared. And then all you have to do is plug that whole thing directly into your calculator, and you get -7/25. Okay, on number 8. This says I am in between 2 pi and 5 pi over 2. So if you think about this, 2 pi is right here, so that means I would be in this quadrant. And this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2. Okay, plus this always tells you the first part of the quadrant and the end of the quadrant. Okay, and in that quadrant, everything is positive. All right, so my double angle formula here would be for sine. So I've got 2 times sine theta. Well, we're going to need information for that. So cosine is adjacent over hypotenuse. So this would be 3, this would be 5, and that makes this side 4. So sine would be opposite over hypotenuse, so it would be 4/5. And then cosine, we already have, which is 3/5. And then I just plug that directly into my calculator, and I come up with 24/25. Okay, so for the equations, you want to get down to either 2 factors. You don't want to have anything mixed within a factor that's like a cosine or a sine. So if I'm down to just cosine 2 theta and a 3, I don't need to do any kind of factoring here because all I have is a cosine. So I'm just going to get the cosine 2 theta by itself. So I'm going to divide by the -3. So that leaves me with cosine 2 theta is equal to 0. So now I'm looking for an angle because I have to take the inverse of this. So looking for an angle that has a cosine of 0. So I'm going to look at my unit circle. Cosine is the x value, so that would be at pi over 2 and 3 pi over 2. So if I think about this, this is really, if I go from this spot, it's pi over 2 plus 2n pi plus 2 pi plus 2 pi. Would keep landing me in this spot. And if I do this one, it would be 3 pi over 2 plus 2 pi plus 2 pi plus 2 pi. So I can denote that by saying plus 2n pi. So I've got 2 theta is equal to pi over 2 plus 2n pi, and 2 theta is equal to 3 pi over 2 plus 2n pi. But I'm not done yet because I have to solve for theta, so I'm going to divide by 2. So I get pi over 4 plus n pi. And then same thing over here. So I get 3 pi over 4 plus n pi. Now I can't leave it like this. This would be every single answer for infinity. But I only want to go from 0 to 2 pi. So every answer has to be between 0 and 2 pi. So if I think about this, I start at pi over 4. And I'm going to keep adding pi until I get to a number that's bigger than 2 pi. Then I've gone too far. So I take the pi over 4, and I'm going to add pi. and I get 5 pi over 4. And then I'm going to add another pi. Now I'm at 9 pi over 4, but the biggest number we could get would be 2 pi, and even that's too big. We don't include the 2 pi. So that is bigger than 2 pi, all right, because 4 goes into 9 2 times with 1 left over, so it's actually 2 1/4. So we don't want to go bigger than that. So this number is too big, so now I'm going to switch over to this one. So I start at 3 pi over 4 is one answer, and I'm going to go ahead and take 3 pi over 4 and add pi. So I've got 3 pi over 4, and then I'm going to add pi. So 7 pi over 4. And then I'm going to add pi again. That's bigger than 2 pi because 4 goes into 11 2 times with 3 left over. So it's actually 2 3/4 pi. So that number is bigger than 2 pi. So these are my only angles. So all of these are the answers that would satisfy this equation. All right, so here I'm going to do the same thing. I'm just going to solve for this 2 sine theta. So I add the 3. So I get 0. So sine 2 theta is equal to 0. I'm going to get rid of the sine. So I do the inverse. So I'm looking for angles that have a sine of 0. So I look at my unit circle. Sine is the y. So that would be 0 and pi and 2 pi. But if you look, we don't include 2 pi. There's not an equal. So we're just going to say 2 theta plus equals 0 plus 2n pi, and 2 theta is equal to pi plus 2n pi. So I divide by 2. So I've got theta is equal to 0 plus n pi. Same thing on this side. Theta is equal to pi over 2 plus n pi. So again, I'm looking for numbers that are going to be smaller than 2 pi. Okay, so I start with 0 and I add pi. So 0 plus pi is pi. All right, and then I add pi, and that would give me 2 pi, but we're not including 2 pi. And I know it's on my answer key because I just caught that, but 2 pi is not an answer. We don't include the 2 pi. All right, so that's too big. So now I'm going to start with the pi over 2, and I'm going to add pi to that, so that would give me 3 pi over 2. And 2 will only go into 3 one time, so I haven't made it twice yet. And then if I added another pi, that would be 5 pi over 2. So 5 pi over 2 is bigger than 2 pi because 2 goes into 5 twice with 1 left over. So it goes in more than twice, so we only have 4 answers. All right, number 11. So I see that I have the tangent here that has a power of 1, and I have a number without a tangent, and then I have a tangent squared. So that leads me to believe that I have a trinomial that I'm going to have to factor, just like in algebra 2. So I have tan squared plus 2 tan theta plus 1. And like I talked about in class, if you don't like looking at the trinomial like this, think of tangent as being x. So replace everything, every tangent theta with an x. So this would be x squared, this would be 2x, and this would be 1. And then factor like normal. So there's a plus in the back, so you have 2 of what's in front. an x and an x, and then 1 times 1 is 1 and adds to make 2. So now I'm just going to replace the x back with tangent theta. So you only need to set one of these equal to 0. So I'm going to subtract the 1. So I have tan theta is equal to negative 1. Do the inverse. So I'm looking for an angle that has a tangent of negative 1. So that's when you take the y and you divide it by the x, you get negative 1. So those are all of these middle ones would make 1 or negative 1. So if I divide these two, that's 1. Here, if I divide these two, that's negative 1. And then if I divide these two, that's also negative 1. So, go back. So I've got theta is equal to 3 pi over 4 and 7 pi over 4. Now, since we don't have that number in front of this theta, so we don't have to worry about the plus n pi and all of that, okay? Because you're not dividing anything or altering it, so these are the only two angles that are going to give you that. Okay, this one looks super scary, but it's really not that bad. If you have a bunch of stuff, get it all on one side. And maybe sometimes that isn't, going to be the best way, but most of the time it is. So we've got negative square root of 2 times sine theta cosine theta. And 2 sine theta minus 3 sine theta is negative 1 sine theta. So you have two terms here. You have this big long one, and then you have this one. And you notice, and this is equal to 0. So you notice right here that you've got a bunch of stuff. You've got sine, you've got cosine, and you can't set these equal. They're not two separate factors. But you can factor out a common factor. They're both negative, so take out a negative, and they both have a sign. So take out a sign. So if I divide this by negative sine, that's going to leave me with square root of 2 and cosine. And if I divide negative sine theta by negative sine theta, I get positive 1. So now I have one factor right here that I can set equal to 0, and then I have one factor right here. So I'm going to set both of them equal to 0. So here I just divide by negative 1, so I get sine theta equals 0, and then do sine inverse. So I'm looking for an angle that has a sine of 0, and sine is your y. So that would be 0 and pi. Remember, we are not including the 2 pi because we're not equal to 2 pi. So 0 and pi. Over here, I need to subtract the 1. Divide by the square root of 2. And then I need to rationalize this. So I get negative square root of 2 over 2. And then do the inverse. So I am looking for an angle that has an x value of negative square root of 2 over 2. So that would be 3 pi over 4 and 5 pi over 4. Okay, So we are simplifying. And whenever you see a bunch of sines, being multiplied, and cosines, it should remind you of the formula with the u's and the v's. So if I look at this, I've got sine u, so I'm going to make the 4 theta the u, and then theta is v. So then I have cosine 4 theta, so this is uv. So sine u cosine v plus cosine u sine v. If I'm looking at my formulas, that is the same thing as this one. Now, I do think it's a little backwards as cosine u and sine v, right? But that's the same thing. So as long as you've got 2 on this side and the 2 on this side that you're supposed to have, you're fine. So that is my sine sum formula. So it's sine of u plus v. This is sine of 5 theta. Same thing on this one. Make that your u, make that your v, u, and your v. So you have sine u cosine v minus cosine u sine v. So you just match that up. That's going to be if you think of it like this, it's got the minus sign, okay, which is going to make it the sign difference formula. So you have negative 2x minus negative 3x, which is actually going to change this to a positive. So I have negative 2x plus 3x, so this will be sine of x. All right. So 7 pi over 12. That is not on this unit circle. So you need to find 2 angles that will either add to make that or 2 angles that will subtract to make that. So it's hard to do that in radians. So let's change it to degrees. So in order to cancel the pi, that's on bottom, and pi is the same thing as 180. So I'm just going to cancel those and do 7 times 180 divided by 12. So I've got 7 times 180 divided by 12. So that gives me 105 degrees. So this is really the same thing as cosine of 105 degrees. Okay? So I know that if I were to add 60 and 45, that would get me 105 degrees. So I'm going to use the cosine sum formula. So I've got cosine of 60 times cosine of 45. Remember, with the sum, it's always minus, plus you have your formula right in front of you. Sine of 60, sine of 45. Okay. So sine of 45 minus 30. So I'm going to use the sine difference formula. So I've got sine of 45 cosine of 30 minus sine of 30 times cosine of 45. And you can just plug in directly from there and you get the square root of 6 minus the square root of 2 over 4. I will tell you this. You can actually plug this directly into your calculator. It tells you what it is. But if you mess up for some reason, you know, I want to see this. But this is a good way to check yourself. So if you plug this in, you have to make sure you're in radians. If you plug this in, you have to make sure that you're in degrees. All right, so these are already put into a formula. So if you start off with two cosines, you're obviously a cosine formula. Since you're subtracting, it's going to be the sum. So you've got pi over 18 plus 7 pi over 9, which gives you the cosine of 5 pi over 6. And if you go to 5 pi over 6, the cosine is negative square root of 3 over 2. All right, this is obviously a tangent formula, and since there's a plus on top, it's the sum. So tangent of 13 pi over 18 plus 4 pi over 9. I add those two numbers together, I get tangent of 7 pi over 6, which gives me square root of 3 over 3. All right, so sine to the fourth would be the same thing as saying sine squared x times sine squared x. And if I replace those with the power reducing formula, I get 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. So if I multiply those together, I get 1 negative cosine 2x and negative cosine 2x gives me negative 2 cosine 2x, and then plus cosine squared 2x over 4. Now I don't want the 4 out there, so I'm going to go ahead and factor out a 1/4. And then I need to go ahead and power reduce this. So I've got 1 minus 2 cosine 2x. And since this is squared, that means when I power reduce here, it's going to be 1 minus 1 plus, cosine 4x. So you're going to have to double that over 2. So I don't like that I have a fraction here, so I'm going to go ahead and multiply both of these by 2 over 2 so that I can have a common denominator. So I've got minus 4 cosine 2x over 2 plus, and then I'm going to separate this into 1/2 and cosine 4x over 2. All right, so I'm going to go ahead and factor out a 1/2, which is going to make this 1/8. And I'm going to go ahead and combine my like terms. So I have a 2 and a 1, which make 3. And then I have minus 4 cosine 2x plus cosine 4x. And I don't have any powers that are bigger than 1. Okay, last one, I've got sine squared. So I know that that's 1 minus cosine 2x over 2. And then I know that cosine is 1 plus cosine 2x over 2. And the nice thing about this one is that when I multiply these tops, I'm actually going to cancel out the middle. So I get 1, and then you get a positive cosine 2x, and a negative cosine 2x, and then negative cosine squared 2x all over 4. So I'm going to take out 1/4. And then I'm going to go ahead and power reduce this. So I've got 1 plus cosine 4x over 2. And I don't want to forget this negative, so I'm going to go ahead and distribute it through the top here. And I'm going to multiply this by 2 over 2 so that I can get a common denominator. So I've got 2 over 2, and then minus 1/2 minus cosine 4x over 2. So now I have a common denominator. I'm going to pull that out. That makes 8. 2 minus 1, 1, and then you have your minus cosine 4.